Good day, everyone. Today, we are going to be talking about set theory. Now, if you're talking about set theory, what does set theory means? Set theory simply means the theory of sets. Then, what is a set? What do we mean by sets? Set simply means the collection of distinctive members. Simply, the collection of members. That is what set means. So, set collects some members together. So the members of a given set can be referred to as elements or belongs. The members that are present in a given set can be referred to as what? Element or belong. So therefore, you have to understand something, that whenever you hear set, set simply means the collection of some particular members. These members that are present in a particular set can also be referred to as elements or belong. So therefore, what can we represent a set as? We all know that a carton of Indomie consists of Indomie. Then we can say that that carton is a set. Why the Indomie inside that carton are the what? Members of that set. Let's move on. Then you have to understand that the set theory are usually being represented by capital letters. Capital letters A, B, C, or D, etc. But also, we can represent the members of a given set either by letters or by numbers or by symbols. If we are going to represent the members of a given set by letters, then you should represent the members of a given set by small letters. Do you get that? So we represent the sets by capital letter, but we represent the members of the set by small letters. So you can represent the members of a set by symbols, either plus, minus, alpha, gamma, etc. And you can also represent the members of a set by numbers 1, 2, 3, 4, 5, etc. I can also represent it by small letters A, B, C, D, etc. Okay, that is that. So therefore, a given set can be represented as capital A equals A, B, 1, 2. Now, before we move on, you also have to understand that basically or generally, we can have three types of brackets. Types of brackets or braces. We can have the open brackets, and this is represented as this. We can have the closed brackets, and this is represented as this. And we can have the curly brackets, and this is represented as this. So out of these three types of brackets, the one we use in set theory is what? Curly brackets. So therefore, you have to know that since set means the collection of members, then the members of a set are usually being enlisted in a curly bracket. Now, we can also refer brackets to as braces. So they can ask you that what type of braces do we use in listing the members of a given set? That is a what? Curly braces. The next thing you also have to notice is that the members of a given set are usually separated from each other by comma. Do you get that? So the members of a given set are usually separated from each other by what? Comma. That is that. Then the next thing we have to talk about now is what we refer to as cardinality. Cardinality. In a simple word, whenever you hear cardinality, we can refer it to as number. What does cardinality mean in sets? Cardinality simply means the number of elements that is present in a given set. That is, in this set, how many elements are present. So the number of elements present in a given set is simply referred to as what? Cardinality. The number of elements present in a given set is simply referred to as cardinality. Then note, the cardinality can also be called order of a set. The cardinality can also be called the order of a set. Okay, and there is a representation for this cardinality. We usually represent the cardinality or order of a set by n. N. Because in a simple manner, cardinality simply means what? Number. The number of elements present in a given set. So therefore, if my set A equals AB12, I've already known that I usually represent my set as capital letter. I represent the members or the elements in that given set by small letters or numbers. And these elements are usually enlisted in a curly bracket like this. Then I can know that in this particular set, how many members are present. So in this particular set, you are going to see that we have 4 members. This simply means that the total number of members in this set A are what? Are 4. So therefore, the cardinality of set A is 4. The cardinality of this set A is 4 because in this set A, we only have what? 4 distinctive members. The next thing you have to notice that if I don't want to use the word cardinality, I can also say that n of A is equals to 4. This n simply means the cardinality, the number of A, that is the number of members in A is 4. So n of A is 4. So that you have to understand. The next thing we are not going to talk about now is you have to understand that if we are defining set theory, or basically sets, if you are defining sets, set is a collection of distinctive members. That is to say, the members in a given set must be distinct from the other. And that is why in a given set, repetition of elements are not allowed. The repetitions of elements are not allowed in a given set. So therefore, since we have already said that in a given set, the repetition of the same element are not allowed, this simply means that set A, which is equals to 1, 2, would be the same thing as set B, which is equals to 1, 1, 2, 2. The cardinality of sets A and B is 2. So you have to understand that sets is a collection of distinctive members. So the members of a given set must be distinct from each other. And that is why we say that repetition of the same elements in a given set are not allowed. So therefore, set A, which equals 1, 2, is the same as this set B, which equals 1, 1, 2, 2, because the repetition of these elements will not be considered. Whenever the same elements are repeated twice, then we are going to represent those repeated elements as just one. And that is why we say that the cardinality of set A and set B is 2. So the cardinality of this is 2. The cardinality of set B is also what? 2. The reason why the cardinality of set B is also 2 is because in set theory, the repetition of the same elements are not allowed. So therefore, we are going to refer, or we are going to count this same element as just one element, and this one also as just one element. Okay, thank you. The next thing we are going to move on to now is the types of sets. Okay, guys. So let's talk about types of sets. If we are talking about this type of sets, then we have to know that what are the types of sets we have in set theory. The first one I'm going to talk about today is finite and infinite sets. The second one is singleton sets. This one should be singleton. Singleton sets and empty sets. The next one should be equal sets and equivalent sets. But before we are going to talk about all these type of sets, let me show you guys something. You know, previously, when we defined sets, we said that set is a collection of distinctive members, right? And we say that the members of a given set can also be referred to as elements or belong. So you have to understand something, that members or elements, members or elements of a set can be represented as this sign. So this is the symbol that is representing the members or elements of a given set. So therefore, guys, let us say that A equals A, comma B, comma 1, comma 2. You are, by now, you all have understood that this capital set, this capital letter A, represent the sets. While this small letter B, A and B, 1, comma 2, represent the what? Members of the set. Therefore, guys, I can say something, that this A is a member of this set A. This B is a member of this set A. This one is a member of this set A, and this 2 is a member of this set A. But if I don't want to say it, I can then represent it mathematically as this. I can say A is an element of capital letter A. So this sign simply means element or members of a given set. Since this A is an element of this set A, then I can say that this A is an element of A, or I say that this A belongs to A. We can also say that B is an element of A. We can also say that 1 is an element of A, and we can also say that 2 is an element of A. But guys, if we check these given elements very well, you're going to see that C is not found in this element. Therefore, we can say that small c is not an element of A. So therefore, this simply means that this represents elements, while this represents not an element. So C is not an element of A because in this set, C is not there. You can also say that 3 is not an element of A because in this set, the members in the members of this set A, 3 is not there. Do you understand that? Okay, guys. Now let's move on to types of sets. So, guys, if we are talking about the types of sets, we will start with finite and infinite. Okay, guys. We all know what infinity means. Infinity simply means that when something has no end, right? That is what infinity means. We all agree. Okay, then you have to understand that infinite is coming from infinity. Do you get that? The opposite of infinite is finite. So therefore, you have to understand that whenever you hear finite set is a set that has a countable members. Finite set is a set that has a countable members. While infinite set is a set that has uncountable members. Do you get that? Infinite set is a set that has what? Uncountable members. That is what finite and infinite set means. Let's look at some example. Let us say finite and infinite. Let us say set A equals A, B, C, and set B equals A, B. Let me use 1, 2, 3, ... Now, you have to be very careful here. What does this mean? In this set A, this simply means that we have only just 3 elements. A, B, and C. So therefore, A is a finite set. But if you check this set B, we have 1, 2, 3, ... And this simply shows that the members of this set B has no ending because it is what? ... So therefore, B is infinite sets. Let's see another example. Let's say we have set C equals days of the week, and set D equals stars in the sky. Everybody, let me ask you a question. How many days do we have in a week? 7, right? We have 7 days in a week. So therefore, the members of set C are 7. So therefore, set C is also a finite set. But let me now ask another question. You, as a scientist, how many stars are present in the sky? Can you even count? There is no instrument you can use to count the number of stars in the sky. Because when you are done counting the number of stars in the sky for Nigeria, you will also go to Ghana, you will also go to USA, and you won't be what? You won't be able to count everything. So therefore, the stars in the sky are uncountable. So therefore, we can say that set D is infinite sets. Okay, so that is that. So a set in which the members can be counted can be referred to as what? Finite sets. While in sets in which the members cannot be counted or in which the members are uncountable can be referred to as what? Infinite sets. Then guys, let's move on to the next one. Singleton sets and empty sets. Singleton sets and empty sets. Guys, you all know what empty means. That is when there is nothing. That is when there is nothing. And you all know what singleton means. You may not know singleton, but you know what single means. Right? We all know what single means. Single simply means one. So singleton is coming from single. So therefore we can say that singleton set is a set that consists of only one element. Singleton set is a what? Is a set that consists of what? Only one element. Why empty set is a set that consists of no elements. Empty set is a set that consists of what? No elements. So therefore, guys, you have to know that singleton sets can also be called unit sets. Examples of this singleton set can be this, or this, or this. So guys, since we've already known that singleton set is a set that consists of only one element, then you have to know that singleton set can also be called unit set. You know, whenever you hear units, it simply means one. Talking about one thing. Do you get that? So singleton set can also be called what? Unit set. Example of a set that consists of only one element. It can be set containing of only one zero, or sets containing of what? Phi. This symbol represents phi, phi, or president of Nigeria. Let me ask you a very simple question. How many presidents do we have at a time in a particular country? We only have one president. We have only one president. We have only one vice president. So therefore, this simply means that we only have one president in Nigeria. Do you get that? Okay, that is that. Then let's talk about the next one. Empty sets. Empty sets. Or void. Or null sets. So guys, as it has been already said, empty set is a set that contains no element, that consists of no element. So therefore, you have to know that this empty set can also be referred to as void set, void, or null set, N-U-L-L, null set. So they ask you that, what is a void set? A void set can also be referred to as an empty set which contains no element. It can also ask you that, what is an empty a null set? A null set is an empty set which contains no element. Do you get that? So let me give you an example of empty sets. You see, if you want to denote an empty set, if you want to represent an empty set, we have two things that we can usually use to represent an empty set. It can be represented as this or this. The only two symbols we use in representing an empty set is this or this. If you are using this symbol, which means phi, if you are using this symbol to represent an empty set, you must not place it inside a curly bracket. You are going to write it out without being inside a curly bracket. And if you are using a curly bracket to represent an empty set, then you must not put anything inside the curly bracket. So therefore, you can either represent an empty set by a phi, which is not inside the curly bracket, or an empty curly bracket. That is what we usually use to represent our empty set. Now, what is an example of an empty set? An example of an empty set. Okay, let's say, example, A equals female president in USA. We all know what USA means. That is United States of America. Is there any female president in the USA? Oh, in the past few years, has there been any female president in USA? Or presently, the president in USA, is he a female president? No. So therefore, set A is an empty set. That is to say, A equals this, or A equals this. So set A is an empty set because this set A contains or consists of no element. There is no female president in USA, So therefore, set A is an empty set. It has no element. So we can represent set A to be equals to empty curly bracket, or you represent set A to be equals to what? Phi. So do not forget, if you are representing an empty set with curly bracket, you must not write anything inside that curly bracket. And if you are representing phi as your empty set, you must not place this phi inside the what? Curly bracket. So guys, let's go to the last one, which is what? Equal sets and equivalent sets. Guys, it's very simple. As it is very simple, it might also be somehow confusing. But just listen very well. If we are talking about equal sets and equivalent sets, they are closely the same, but not. So you have to get your facts right. You see, if you are talking about a particular set equal to another particular set, you have to understand that a given set will only be equal to another given set if and only if the two sets has the same members, irrespective of the arrangements. Listen again. A given set will only be equal to another set if and only if the two sets has the same members, irrespective of the arrangements. But if you're talking about equivalent sets, a given set would be said to be equivalent to another given set if and only if these two sets has the same cardinality. Have the same what? Cardinality. Guys, let me remind you, what do we mean by cardinality? Cardinality simply means the numbers of members in a particular set. That is what cardinality means. So if we have two sets that has the same cardinality, then we can say that these two sets are what? Equivalent. So guys, listen to this. If you're talking about equal sets, that simply means same members, irrespective of arrangements. But if you're talking about equivalent sets, this simply means same cardinality. So you guys would agree with me now that equal set is for same members, equivalent set is for what? Same cardinality. Let's look at some example. Guys, let's say set A equals A, B, C. Set B equals 1, 2, 3. Guys, let me ask you a very simple question. Set A and do not have the same members? So, since set A and B do not have the same members, please guys, are they equal? No. Because before a particular set would be said to be equal to another set, then they must have the same members, irrespective of the arrangements. So therefore, set A and B are not equal. But let me ask another question, guys. What is the cardinality of set A? It's 3. That is 3. We have 3 members there. So the cardinality of set A is 3. What is the cardinality of set B? That is also 3. Because we also have 3 members here. So therefore, set A and set B, they have the same cardinality. And guys, whenever two sets have the same cardinality, are they equal or equivalent? Yeah? They are equivalent. So therefore, we are going to say set A and B are not equal, but they are equivalent. They are not equal, but they are equivalent. So if I ask you that, why is it that set A and B are not equal? Why? Because they do not have the same members. They have different members. But why is it that set A and B are equivalent? Because they have the same cardinality. The cardinality of set A is 3, while the cardinality of set B is also what? 3. Do you get that? Okay, guys, let me give you another example. Guys. Let's see. Set A equals ABC and set B equals BAC. Okay, let me ask you a question. If set A equals ABC, please guys, what is the cardinality of set A? That is 3, because it has 3 members. So the cardinality of set A is 3. Guys, what is the cardinality of set B? That is also 3, because the cardinality of set B is also what? It's also 3, right? So the cardinality of set A is 3 because that's 3 members. The cardinality of set B is also what? 3, because also has what? 3 members. Now, guys, let me ask you a question. What are the elements in set A? A, B, C. What are the elements in set B? B, A, C. Guys, do they have the same elements? Yes, they have the same elements. The only thing that just differ is the arrangement. Do you get that? So therefore, when two sets have the same element or the same members, irrespective of the arrangement, the two sets are said to be equal. But if two sets also have the same cardinality, the two sets are also said to be equivalent. So guys, if I ask you that, these two sets, are they equal? Yes, they are equal, because they have the same members, irrespective of the arrangement. Guys, are they equivalent? Yes, they are also equivalent, because they have the same cardinality. The cardinality of A is 3, the cardinality of B is 3. So therefore, they are what? Equivalent. So we are going to say that sets A and B are equal and also equivalent. So guys, you already know why they are equal, and you already know why they are equivalent. They are equal because they have the same members, irrespective of the arrangement. And they are also equivalent because they have the same cardinality. Let's look at one more example. Let me use set C and D now. Let me use 1, 3, 4. D equals 2, 3, 1, 4. Guys, listen and listen very well. Do not forget your facts. For equal sets, they must have the same members, irrespective of the arrangements. For equivalent sets, they must have the same cardinality. Guys, let me ask you a question. Let's look at this together. For this set C, what are the members in set C? 1, 3, 4. For this set D, what are the members in set D? 2, 3, 1, 4. Guys, do they have the same members? Do they have the same members? They do not totally have the same members, because in set C we have 1, 3, 4, but in set D we have what? 2, 3, 1, 4. So the element 2, which is present in set D, is not present in set C. So therefore, set C and set D do not have the same members. Do you get that? So therefore, since set C and set D do not have the same member, then we can say that set C and D are not equal. So a particular set will only be equal to another particular set if all the members in the first set is the same as all the members in the second set. But if one element should be different from the two, then they are no more equal. Another thing, guys, let me ask you a question. What is the cardinality of this set C? That is, how many elements are present in this set C? That is 3. The cardinality of set C is 3. Now, what is the cardinality of set D? That is 4. We have 4 elements in set D, but in set C, we have 3 elements. So, guys, let me ask you a question. Are they also equivalent? No, they are not equivalent because they have different cardinality. A particular set will be said to be equivalent to another set if they have the same cardinality. But once their cardinality is different, then they are no more equivalent. So, guys, do you permit me to say that sets C and D are not equal and also are not equivalent? So, guys, set C and D are not equal because they do not have the same elements. Why also set C and D are not equivalent? Because they do not have the same cardinality. So finally, guys, let me ask you a particular question. According to all the examples above, I want to ask you 2 questions. The first question is that, are all equal sets equivalent? Are all equal sets equivalent? Yes or no? Okay, let me ask the other one. Are all equivalent sets equal? Are all equivalent sets equal? What's the answer, guys? Okay, let me just help you out. Guys, you have to understand something, that all equal sets must be equivalent. All equal sets must be equivalent. But all equivalent sets are not necessarily equal. You can jot that down also, guys. Note, all equal sets are equivalent, but all equivalent sets are not necessarily equal. So, guys, should I explain this for you? Let me do that. If you say all equal sets are equivalent, this simply means that once a particular set has the same element as the other set, they must have the same cardinality. That is, look at this. In this example, you're going to see that the set A has what? ABC. While the set B also has what? BAC. So they have the same sets. So therefore they are equal. But also their cardinality is also equal. But now look at this. You're going to see that these 1, 3, 4 in set C are also present in this set D. But set D has 2, which is not present in set C. So therefore, although they wanted to have the same members, but the cardinality is different. So that is why all equal sets are equivalent. That is, before a particular set will be said to be equal to another set, firstly, they must have the same cardinality, and secondly, they must have the same members. But all equivalent sets are not necessarily equal. All equivalent sets are not necessarily equal, or are not always equal. Look at this. They're going to say that this set A has the same cardinality as set B, so therefore they are equivalent. But they're going to say that the element in set A are different from the element in set B. So therefore, they are not equal. So that is why we say that what? All equivalent sets are not necessarily equal or are not always equal. So guys, we are going to move on to operation of sets in our next video. So thank you for watching. Please do not forget to like, subscribe, share, and comment on this video. See you in my next video. Thank you guys.